See the question here. Okay, this is the first seed of this question. See carefully, which I will solve this question to this video. Okay, second page is this. Okay, third page is this. See the question. Fourth page is this. Okay, this is the fourth page for the competitive exam, which I make this question, and some competitive exam question is there. Okay, see, this is the last page. And follow my video. Okay. Welcome to my channel, everybody. And today this is the very important class for join IIT Advance, all of the competitive exam. Okay, see the solution here, and some question are given 1 to 14 here. See, for the first question, where omega be the cube root of unity, then we have to show this is actually be 0. How it possible? See, for question number 1, a b omega c omega square whole to the power 4, a omega b omega square c omega to the power 4. In my question, there was this part given as wrong. So now corrected equation is this: a omega square b plus c omega whole to the power 4 here. Now these are the fixed: a plus b omega plus c omega square whole to the power 4, and take common as omega, but here is omega is absent. So compare with that, we have to express as a factor of the each of the this remaining 2. Okay, so now a omega plus b omega, so we want to take a common omega, as here is omega is free, so that's why, but here is omega is absent. So this is b omega square and c omega cube, and omega cube is equal to 1 for cube root of unity, and we have to take a common omega square, but omega square is absent here. So now we can put like that b omega cube, as the omega cube here 1, or c into omega to the power q here. Okay, to the power 4. So now c a plus b omega and c omega square whole to the power 4, and take a common omega to the power 4, a plus b omega c omega square whole to the power 4. Again take a common omega to the power square, and this is power to the power 4, so 8. A b omega plus this is 4, and take a omega square, so this is here omega square whole to the power 4. And now see, these three parts are same, so a plus b omega plus c omega square, so this is here 1 plus omega to the power 4 plus omega to the power 8. And now see, and this is here 4, and now remaining these are omega cube means 1, so we can here write 1 plus omega cube into omega, so this is here omega, and omega to the 6 means 1, remaining all are omega square. So the sum of the three cube roots of unity, b has 0, so this is b 0 here, so answer is option B. Now for question number 2, we have to find the least value of m, for which is satisfied. And now for question number 2 here, 1 plus I and 1 minus I to the power n, and that is equal to 1. Now see, 1 plus I whole square and 1 minus I square to the power 1 here, and this is I square means minus 1, this is plus 2, and this is your 1 plus 2i plus I square means minus 1, and this is your minus 1 to the power of n equal to 1. So 1 cancel, and I to the power n is equal to 1, and which value is satisfied for least value of the n. If you put here 0, but as except 0 here is absent. So now if we put here 2, then we get here minus 1. So if we put here 3, then we get here minus I. But if we put here omega to the power 4, I to the power 4, then we get here 1. So least value of n is 4. Okay, so 1 or 2 have complete. Now see next question. For 3, this is given twice a minus 5b plus 3c equal to 0, and the line here is ax plus by plus c is equal to 0 here. But see here, this is 3, so but here is c, so divided by 3 we get here 2 by 3a, 5 by 3b plus c is equal to 0. Compare with this and this. If we put in place of x, this is 2/3, and in place of y minus 5 by 3, then we get this condition. So what is the point here? 2 by 3 minus 5 by 3. 2 by 3 minus 5 by 3, option C is satisfied. Okay, I think better understood all of you. Okay, now we have to proceed to this question number 4. So very interesting question. Alpha be the roots of this equation. So we can easily write here a alpha square b alpha plus c is equal to 0, and a beta square b beta plus c is equal to 0. And now we have to show then this is the root of the equation. This is 4. This is the root of the equation of question is missing here. So right here ax square minus bx plus c equal to 0. Actually this is your question. Okay, and if alpha beta be the root of this equation, now show that which root satisfy this equation. This is c here. Now we compare with these two. If we put ax square minus bx plus c is equal to 0, if we put my alpha minus beta, what we get here? A alpha square minus b alpha plus c is equal to 0. But this does not match. So now if we put b, if we put the quotient minus b minus beta, then what we get here? C, that is a alpha square plus b alpha plus c is equal to 0. Again, if we put here beta, so a beta square plus b beta plus c equal to 0, and these two conditions satisfy these two equations. So option B is right here. Okay, option B is right here. Now proceed to the question number 5. Question number 5. See carefully. That is 5 here. And what is the f of x? Now 3 f of x minus 1, f of 1 minus x by x is equal to twice x. So 3 into f of x minus 1 minus f of 1 by x minus 1 equal to twice x. Okay, replacing 1 by x in place of x. Then 3 into 1 by x minus 1, okay, and minus f of x minus 1 is equal to 2 by x. This is 1 and this is 2. Okay, now we have to find f of x. Now multiply by 3 here. So this is here 9, this is here 3, and this is here 6. Adding 1 plus 2, and this is here this minus this, so 8 times of Okay, no, this is here 3, this is here 1, this is here 2. Now we want to cancel this part, then calculation will be easy. So multiply by 3 this equation. So 9 times of f of x minus 1. So this is 3 times of f of 1 by x minus 1. And this is 6x. And this is 3. Okay. Now adding these two. So these two are cancelled. This minus this. So 8 times of f of x minus 1. And this is equal to 2 by x plus 6x. Now replacing x plus 1. So this is here x plus 1 minus 1. This is x plus 1 and 6 into x plus 1. So 1 cancel. So 8 into f of x. So that is 2 by x plus 1. That is 6x plus 6. So f of x is equal to this is 1 by 4 times of x plus 1. And this is 6x by 8 and 6 by 8 here. So option is for question number 5. Option is here 1 by 4, 1 by 4, 1 by this is here 1 by 4, 1 by x plus 1, and this is 1 by 4, and this is 3. Option number B. Answer is B here, satisfied. Okay. So this is 3x and this is 3 by x. Okay. Option B is answer. Okay. I think better all understood. And now proceed to the question number 6 here. See, 2 curves are given and then locus is what? So number 6 for that, x cos theta plus y sin theta is equal to a. X sin theta plus y cos theta is equal to, actually this is here b, wrongly written, this is b here. Now squaring both sides and adding. So what we get here, see, y sin theta, okay, x sin theta plus y cos theta, and that is a square plus b square. So x square and cos square, x square sin square, y square sin square theta, y square cos square theta. Okay. Okay, there is also some mistake here. This is given here minus, so I am wrongly written. So twice ab plus twice ab are cancelled. So this is a square plus b square. So now see, this is a x square plus y square equal to a square plus b square. Okay. Okay. So some silly mistake are given. So number C is the right answer. Okay. Now follow to the question number 7. Question number 7. And this is C option. And question number 7, see carefully. Some of the more students are applying the LaHospital rules, but it is easy to the normal form, that is cos x by x square here. Now multiply by 2, then limit x tends to 0. For that log of cos square. So cos square x, so this is limit x tends to 0, so this is 2x square, and log of 1 minus sin square x square, so limit x tends to 0, and log of 1 minus sin square x square. Okay, and this is minus sin square x square and minus sin square x by 2x square, and this is here 1. And this is here 1, so this is minus half. Okay. So 7 is complete, and all of the 2 7 complete. And question number 8 here. See question number 8. See the question number 8 here. Very interesting question. And now find the number of digit of that, and given that the log 2 is this and log 3 is that to the base 10, and now how many digit of that number. So apply the logarithm theorem. It is possible to solve easily. 18 to the power 30, and now take like a and take a logarithm of that. C that is 30 into log 18 to the power 10 to the base 10. Okay, 30. This is here log 2 and log 9, and this is 30 into log 2 to the base 10 and 2 log 10 to the base 3. So 30 into this is log 2 here 0.3 0103 plus 2 into this is 0.47712. If we multiply, then we get here 37.65 37.65 something. So it's mentioned that the number of digit we had 38. Okay, so if the integer be a whole number 37, so next number we want to be added, and then the number of digit of that figure is 38 here. And okay, but we already see the question number 9 here. So see 9 here is y suffix I plus y suffix I plus 1 is equal to this is given k, and also given that the y suffix 8 equal to 1. Now we have to find the y1, and now see here y, if we put here 7 and then we get here y8, and this is k, and this is here 1. So y7 plus 1 is equal to k, so y7 is equal to k minus 1. Again, if we put here and 6, then this is here 7 and this is k, and 7 here is y6 plus y7. y7 means k minus 1 is equal to k. K here cancel, so y6 here 1. So even suffix be 1 and odd suffix be here k minus 1. Even suffix be 1 and odd suffix be here k minus 1. So and that from that logic, and this is the odd suffix, so this is the odd suffix, this is y suffix 1, and this is y suffix 1 means here k minus 1 actually. So your answer is number 3rd. Okay, so see for question number 10, and now see here, and this is need to follow that. So all of the most of the student just follow the summation method, but not needed to the find the sum of that. Okay, and see if we put here n equal to if 1, then the left hand side here is 1. Now we want to get if we put here 2, then some left hand side right here this is first and second sum, their addition be 3 plus 1 4, and this is 4 here. So now on the right hand side, if we put here for that right hand side, if we put that on that 1 by 6, this is 3 6 6 6 1. This is also 1 for case number 1. If we put on the again, if we put 2 here, this is 2 by 6, and this is 2 by 6, and this is 2 plus 1 3, and this is 2 plus 2 4. So and 6 6 6 cancel 4. So this part is satisfied. And if we put here 1 on the second part, we get here 3 to the 6, 3 to the 6. But if we put here 2, put here 2, this is 2, 2 to 4 8, more than the 4. Okay, so doesn't satisfy. So option here is 1. Okay, this is your answer. Okay, now for the question number 11, and so we can solve like that. Question number 11 be a same procedure. Okay, now proceed to the question number 12. Question number 12. O be the origin and Q O be the origin. Okay, C O be the origin and Q1 is here x1 comma y1 and Q2 here x2 comma y2. Okay, now C. Okay, now we have to find that cos of Q1 O Q2. If we R1 theta 1, okay, R2 theta 2. So cos of this is theta 1 and this is theta 2. So this is theta 1 minus theta 2. We can write here cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. Cos theta 1 means this is this is x1 by this is r1. Okay, same as this is same as cos theta 2 means this is x2 by r2, x2 by r2, same as y1 by r1, y2 by r2. Take a LCM here, r1, r2, x1, x2, y1, y2. Okay, I think all of you better understood. Okay, this is r1 means OQ1, R2 means OQ2. So this is here cos of Q1 O Q2, and that is here OQ1 and OQ2. OQ2. So this is your answer. Okay, see. Next question, question number 13. See. This is here 2 to the power sin x, 2 to the power cos x is satisfied 2 to the power 1 minus 1 by root x. Okay, the set of all real values of x for which this is satisfied, the set of all real number, positive integer, negative integer, none of them. Okay, so none of this. Now from AM is greater than GM. From that, so half of 2 to the power sin x, 2 to the power cos x, and that is equal to GM. This is root over x plus y by 2 is greater than root over xy. Okay, and that is 2 to the power sin x and 2 to the power cos x, and that is equal to 2 to the power sin x and 2 to the power cos x. This is 2 into 2 to the power sin x, this is half here, plus cos x. So this is 2 to the power 1 plus 1 by root 2, 1 by root 2, 1 by root 2. This is root 2 here, so 1 by root 2, and sine of x plus pi by 4. And now see, sine of x plus pi by 4 is lies between minus 1 2 and plus 1. Okay, then if you put minus 1, so this is the least value. So this is the least value. So that is 2 to the power 1 minus 1 by root 2 here, which is satisfied. Then sine of x plus pi by 4 equal to minus 1 in which cell? On the tan cell. So that is sine pi plus pi by 2. So we can apply the solution from that x plus pi by 4. So n pi minus 1 whole to the power n into 3 pi by 2. Okay, and from that putting n equal to 0, 1, 2, 3, then we got all the solution here. Okay, so set of real numbers, 0, 1, 2, 3, if we put here, set of real number. Okay, and now for the question number 14. And see, actually this question was missing there in my question set. A to the power log x base root 2. So let A is equal to A log x root 2, B to the power log y root b root 2 root a, and C log z. So if we take logarithm on both sides, this is log a, and that x root a log a plus y root b log b plus z root c and log c. So this is here log x by log root a, log root a. This is here half, this is here 2 into log a plus dot 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 dot. This is 2 log x log y log z. So log of x by z whole square, and this is a. So a is equal to x square y square and z square. Okay, option to the question number here. C. Here is C in my question. Option is C here. Okay. For 17. Now C in my question 17. Find the minimum value of x square plus x plus 1 by x, y square plus y plus 1 by y. This is 17. Find the minimum value. Z square plus z plus 1 by z actually. Okay. Find the minimum value of that. Each three expressions are same. So first let as a on the first x square plus 1 by x here divided by x plus 1 by x plus 1 actually, and this is root x 1 by root x whole square plus 2 plus 1. This is there 3. So this is where we can see the least value of for the each expression is 3. So the minimum value are 3 into 3 into 3, and that is 27. Okay, for this is there 15. Sorry, this is there 15. Okay, actually this is here 14, 15. Okay, okay, this is question number. Okay, this is question number 17. Okay, this is question number 17. And now proceed to the 12 number question. Is missing, I think. Yes, actually number are changed actually. And question number 12 is there. Log a to the base 30 is equal to a. Log 30, log 5 to the base 30 here is b. Now we have to find log a base 30. Okay, and see, this is here 30 and this is here 3. Sorry, this is here 3 to the base 30 is a, and log 5 to the base 30 is b here. Now you have to find this. This is q log 2 base 30. Okay, now we have to this is here 2 here, so now we can write here 30 by 2. Actually this is here 30 by 15. Then we get here 2, as base is here 30, so we can write here 30. So this is 3 log 30 to the base 30 log 15 base 30. Okay, this is 3, this is 1, log 3 base 30 minus log 5 base 30. Okay, so this is A or B. 3 times of 1 minus A minus B. Okay, I think all of you have better understood for this question. For this question, so see the question number 18. Very interesting question. In the chapter of domain, a very interesting question is that you have given x is a set of real number. This is your 18. X is a real number and x to the power log x whole square minus 3 log x plus 1 is greater than 1000. Okay, now option A, then set of all solution is what? A option is here 1000 to infinity, B minus infinity to 1000, and C minus 1000 to minus or plus 1000, and D none. So now see the solution here. If we take logarithm on both sides, this is log x whole square 3 log x plus 1, okay, and log x and logarithm log to the base 10. Actually these all are base 10 and 10 cube, this is 3. Okay, let us assume as a and this is as a. So a square 3a plus 1 into a minus 3, and this is 0. If we multiply and then simplify, we get here a minus 3 and a square plus 1 is more than 0. You know this is more than 0, so a minus 3 is more than 0. A means log a to the base 10 is 3, so a greater than 10 cube means 1000. Okay, this is option A. This is option A. This is option A, more than 10,000. Okay, so this is your solution. Very interesting question. Next problem is 90. Very interesting question. See the solution here. Now first 666 m digit whole square and 888 m digit, and that is equal to 444. This is 2 m digit. See 19 here. 6666. This is your n digit, and that is equal to 6 plus 60 plus 600 dot to n term. If there is an n digit, therefore the this is the sum of the n term. So you have to take a common, and then you get here 1, 10, 100 dot to n here, and this is your 10 to the power n minus 1 by 10 minus 1, and this is your 2 by 3 and 10 to the power n minus 1. Okay, now 888 n digit, and that is equal to same as 8 plus 80 plus 800 dot to n digit. Take a common 8, 1, 10, 100 dot to n digit. Okay, 8. This is 10 to the power n minus 1 by 10 and minus 1. This is 9. This is 9. This is 8 by 9, 10 to the power n minus 1. Okay, same as 4, 4, 4, and this is your 2n digit, that is 4, 40, 400. This is 2n. Take a common 4, then 1, 10, 100, divided to 2n. This is 4, 10 to the power 2n minus 1 by 10 minus 1. This is 4 by 9, 10 to the power 2n minus 1. Okay, left hand side, and that is equal to, this is 666 n digit whole square, 888. Okay, and that is equal to 6 means 2 by 3, 10 to the power n minus 1 whole to the power square, same as 888 means this is 8 by 9. Okay, this is 4 by 9, 10 to the power n minus 1 whole square, and 8 by 9, 10 to the power n minus 1. Take a common here, 4 by 9 and 10 to the power n minus 1. So we have left here 10 to the power n minus 1 plus 2. This is 10 to the power n plus 1, 10 to the power n minus 1 and 10 to the power n plus 1, and this is 4 by 9, and this is 4 by 9, 10 to the power 2n minus 1 c, and this is the same, and that is equal to 4, 4, 4, and this is a 2n digit. Okay, so it's proved, left hand side equal to right hand side. Okay, very interesting question for Indian Statistical Institute and others. Very interesting question. Okay, see carefully. Now proceed to the question number 20. Number 20. In case of integral, if we derivative like the ddx of f of x and phi of x, and this is the f of x and dx. If we differentiate, the rules here is this is f of phi of x, okay, and ddx of phi of x. Again, put the place of x, this is f of x, okay, into ddx of f of x. Okay, this is the rules here. And now for 20, see, this is pi by 4 2x under root 3 minus 2 sine square t and dt plus a to y cos t and dt equal to 0. Okay, now differentiate. Now we have to find ddx. Okay, ddx ddx plus ddx, and that is equal to under root 3 minus 2 sine square x, okay, into ddx of x is this minus 3 minus 2 sine square pi by 4 into ddx of pi by 4. This is constant, so 0. Same as if we put here y and cos y and ddx of y minus cos of a into ddx of a equal to 0. See, this is 3 minus 2 sine square x minus, and this is 0 here, plus cos y dy dx equal to 0. So at what point? This is 0 and pi by pi. So therefore 3 minus 2 sine square at 0, x is 0, so 0. So plus cos x means y means pi, okay, and dy dx is 0 and y is 1 pi equal to 0. Cos pi is minus 1 dy dx is x equal to 0 and y equal to pi, and this is equal to minus root 3. Okay, so dy dx at 0 and y equal to pi is equal to root 3. So this is option D. Very interesting question. See carefully, okay? Now proceed to solve into fast. 21st is that this is here ax square 2cx plus b equal to 0. Another is ax square 2bx plus c equal to 0. So C, question is we have to show a plus 4b plus 4c equal to 0. 4c equal to what? We have to find this. In case of that, if we put here in place of x, is here x is here half, then we got the answer. Okay, if we put both half, a into half square 2c into half plus b equal to 0, that is a plus 4c plus 4b equal to 0. Again put here half, a by 4 2b into half plus c equal to 0. So a plus 4b plus 4c equal to 0. Okay, C. So this is option C. C. This is option C. And 21st I've done. Now 22. X minus, this is 22. X minus x square by 2, x cube by 3, brought to infinity equal to y, and that is equal to log 1 plus x to the z. So we can write here 1 plus x is equal to e to the power y. So 1 plus x is equal to 1 plus y by factorial 1, y square by factorial 2, y cube by factorial 3. 1 cancel. So this value is equal to x. This value is equal to x. Option B. Okay. Now 23rd. Coefficient of x to the power n. Coefficient of, we have to find x to the power n, e to the power 2x plus 3. So e to the power 3 into e to the power twice x. So that is e to the power 3 into twice x is 1 plus 2x by factorial 1, 2x whole square by factorial 2, like that. We have to find the coefficient of what, x to the power n. So this is twice x whole to the power n by factorial n. Therefore the coefficient of x to the power n is, this is e to the power 3 into this is 2 to the power n by factorial n. Okay, this is your answer. So e to the power 3, 2 to the power n, factorial n, option V. Okay, for 24, 24 you have given e square, e dash square is equal to 3, and e is the eccentricity of either parabola, ellipse and hyperbola. For parabola e is 1, for hyperbola e is greater than 1, for ellipse e is less than 1. So now this is 3, so we follow the more than 1. We follow the more than 1, so we got then 3. Okay, so if this is less than 1, and therefore the e square e dash square lies between 0 to 2 but does not satisfy. So it is only possible when it is a hyperbola. So it is possible here more than 1. Okay, so e square e dash square is equal to 3. it would be satisfied for hyperbola. Option B. Now 25. Now see the question number 25. Very interesting question. 25 and sine 18. Let us assume x is equal to sine 18. You know sine 18 equal to root 5 minus 1 by 4. This 4x is equal to root 5 minus 1. So this is there 4x plus 1 is equal to root 5. Squaring both sides, 16x square plus 8x plus 1 is equal to 5. So 16x square, 8x minus 4 equal to 0. 4x square plus twice x minus 1 equal to 0. So which equation is satisfied? 4x square plus 3x and minus 1. This is option A. Okay. And now for question number 26. Now for question number 26. If p greater than 0, q greater than 0. Okay. Then the roots are pk and qk. So pk by sum of the roots pk plus qk. Sum of the two roots is equal to minus b by a. This is minus b by a. Addition here is this is minus b by a. P plus q minus n by l. Again pk into qk is equal to this is here c by l, n by l. So p q square is equal to n by l. Okay, sin k. So pq into n by minus n by l whole square by p plus q whole square by n by l. Okay, so minus n by l whole square by n by l, and that is equal to pq whole square by pq, and this is equal to under root p by q by root over q by p. Okay, whole square. Okay, so this is n by l. So n square by l square, then n by l, and this is equal to root over p by q to our q by p. Okay, cancel root over p by q, q by p. Actually this sum is positive, so it would be a positive also. So that is equal to n by, and this is your whole square. So n by l root of that. So root over p by q plus root over q by p minus root over n by l equal to 0. Proved. Okay. Now for the 27, very interesting question is this. This is okay. Now for the 27, x is equal to half log to the power z cot 15. So twice x is equal to log e to the power cot 15. So cot 15 is equal to e to the power twice x. Okay, e to the power twice x. Okay. So now summation 0 to infinity e to the minus twice nx by summation n equal to 0 to infinity minus 1 whole to the power n, it is minus twice nx. This is 1 minus twice x, it is minus 4x to infinity, 1 minus it is minus twice x plus it is 4x to infinity. This is 1 by 1 minus r. Actually 1 by e to the power twice x is cos 15 is less than 1. Okay, so this is 1 by 1 minus r, 1 by 1 minus r, this by this by this, it is a minus twice x. One plus ten 15, 10 15, 10 45, 10 45, 45 plus 15, 10 60. This is root 3 and this is root 3. Okay, now 28. See, very interesting question. Now next question, follow with the next question. 28. You have given x square plus 4x minus 6 is equal to 0, x square 4x is equal to 6. Now log point 0 0 1 and this is x plus 2. As see, this is x plus 2, so that's x square plus 4x plus 4 is equal to 10. So x plus 2 whole square is equal to 10. So now point 0 0 0 1 are root 10. So half log 10 point 0 0 1. So half 1 by log 10 and this is 1 by 1 2 3 4. Okay, so 1 by 2, this is your 1 by 10 to the power minus 4, 10 to the power minus 4. So minus 4 minus 1 by 8, this is here minus 1 by 8. Answer is, the value is minus 1 by 8. Okay, now for 28, very interesting question. Sorry, this is here n less than 1 plus root 2 to the power 6. Okay, now see, 1 plus root 2 to the power 6 is equal to n plus fraction, some fraction. Okay, this is number 1. Okay, now root 2 minus 1 whole to the power 6, that is equal to 1 by root 2 plus 1 whole to the power 6, and that is equal to only fraction. For this fraction, f lies between 0 to 1, same as lies between 0 to 1. If these two are added, so f plus f lies between 0 to 2. 0 to 2. Now this is here root 2 plus 1 whole to the power 6 is equal to n plus f. Okay, and f is equal to root 2 minus 1 whole to the power 6. So n plus capital F plus small f is equal to root 2 plus 1 whole to the power 6 plus root 2 minus 1 whole to the power 6, and that is equal to 2 into root 6 whole to the power 6. Okay, Okay, 6c nc0 nc1 nc2 into root 2 whole to the power root 2 whole to the power root 2 whole to the power 6 minus 2 and 1 to the power 2 6c 4 root 2 whole to the power 2 1 to the power 4 6c 6 2 whole to the power 6 6 minus 2 6 minus 4 and 6 minus 6 and this is 2 into actually calculation here is 198. Actually this is whole thing is 198. Now n plus and this n is equal to minus 8 plus small h, and actually in between them this is the integer here is 1, so 198 minus 1, this is 197. Okay, so the maximum value of n is, this is I think all will be better understood. A very interesting classes today, see carefully. Okay, bye everybody.